Okay. All right, so I'm gonna get through as much as I can, so I'm gonna push you a little bit, okay? And if I don't get to something, I will finish recording it and put it up on Schoology. How does that sound? Okay, because I just want you to do some practice problems for tomorrow. Okay, ready? Let's see if we remember how to do the warm-up. So we have integral of 2/4 root of x cubed minus 4. What we do is, actually, I'm gonna also.
Oh, there's the other.
You split it up, right? But when you see integrals with radicals, we rewrite. So this is 2x to what power? 4/3 or 3/4? 3/4? Yep. And then minus the integral of 4, right, dx. Okay, you can think of it like that. You can split up an integral over subtraction or addition, but not over multiplication, okay, or division. So this becomes 2x to the, you add 1 to the power, which is, what's 3/4 plus 1? It's going to be 7/4.
Yeah.
Now, here's something that I want to make sure you understand. Are you listening? Because this is going to be important for today so that we have to write less work. If I am dividing by 7/4, what could I really just do?
4/7.
I multiply by 4/7. Do you understand? I don't have to write that step. I can just go right to multiplying by 4/7. Do you feel me there?
Yeah.
Okay. That's what I want you to be able to do. And then minus integral of 4 is just 4x. And then plus c. I'm not done because I need to make sure I have no fractional exponents. I don't have any negative exponents, but clean it up. What's 2 times 4/7?
8.
8/7. And x to the 7/4 becomes the what root? What's the root? 4. 4th root of x to the 7th, right? I'm okay with you leaving it like that. I know you could also write it as 8x to the, like 4th root of x cubed is like fully simplified. I'm not going to make you do that. Okay. Yeah, I have to finish the whole problem too. So no, you're fine. So it's minus 4x plus c. And do you know what, like I write equals and stuff, ladies and gents, what does this actually equal? What does an integral become? It is area. At f of x, it's like your original function, right? It's the antiderivative of this function, okay? All right. All right, what came first, the derivative or the integral? Do you actually know? I'm actually legit asking you. I know the answer, do you?
Okay.
What's that?
Look,
You think the derivative?
if it's the derivative because we learned that one first, so that one has to go.
No,
first.
We did learn it first.
I saw this like thing. It's like every egg that you hatch gets closer and closer to 100% chicken, and then if that lucky egg that gives you 100% chicken, so the egg came first.
Okay,
Chicken leg.
listen, are you ready? In calculus, integrals were invented first. Yeah, and then derivatives. But why do we teach derivatives and integrals? It makes a lot more sense that way because we're going to need, you'll see today, we need derivatives to be able to do certain types of integration. Okay? Pretty fun. All right. Anyway.
Is it the chicken or the egg?
Is it the chicken or the egg? Well, you know, I'm not sure. I wasn't around.
I thought that's what you were asking, not
No,
first.
I was asking the derivative.
Oh, I thought it was.
You got it wrong, Ralph.
It's all good. It's all good. But you were right. I mean, the egg was to the integral as the chicken was to the derivative. So you were right. All right. Hey, so today's topic is u-substitution. Shh, guys. Today's topic is u-substitution. This can get a little hairy. It can be a little difficult. But today's going to be fairly straightforward. It's the trig ones that are difficult. Okay. But as we go, this gets trickier and trickier. So you want to make sure you have this down. In order to explain this process, here's the thing. When we're integrating now, we're going to be taking integrals and derivatives at the same time. So you need to know what you're doing. Let's recall, do you know how to take the derivative of this? 3x minus 2 squared. What would you do?
You bring the 2 up.
Bring the 2 in front. So let's call it dy over dx. So you bring the 2 in front times 3x minus 2 to the first, right? We decrease 1 from power. And is that it?
Plus.
Not plus.
Minus.
Nope.
Nope, isn't just time.
Times.
Oh.
What?
And
Chain rule.
times side.
Chain rule. Derivative of what's inside, right?
Yeah.
It's 2 times u to the n minus 1 u prime, okay, or du. So this is going to be, 6 times 3x minus 12. Now, or minus 2. You could distribute, get 18x minus 12. However, do you guys know you could also have squared that, said that's like what? Square, double square. So 9x squared, double the middle term minus 12x plus 4. And you could have used the power rule, right? And you still get 18x minus 12. That equals that, right? So the thing that we need to know, though, is this chain rule. We're going to be doing the reverse chain rule. So it's the chain rule for integration. That is u-substitution. Are you ready? Okay. So what I call these problems are, we're going to be looking for a pattern of f of g of x times g prime, right? The derivative of what's inside. Here's what I call them. U du. Everybody say U du. U du. I call them U du problems. All right. That's what everybody says. All right. It's the U du method. So what we're going to do is we're going to change our x's to u's. So let's see. This is I actually really like these. I think these problems are really rewarding. And you're like, oh, I got it right. Yes, I got another one, right? They're just, I think they're kind of fun because they're a little bit challenging. And when you get them, you're like, I feel so good about myself. Okay, here we go. So looking at this, here's my tip. If there's a quantity, that's going to be the u. If there is a quantity, that's going to be the u. Can you take a guess what I'm going to call u in this problem?
X squared plus.
It's going to be x squared plus 1. Do you see that's the quantity raised to a power? So this is going to be u. To the right, we're going to write u is going to equal x squared plus 1. Because here's what we're going to do. We're going to derive it. What is the derivative of u? If I say du over dx, it is going to be, I heard 2x, right? Yeah. Do you agree? Du over dx would be 2x, right?
Yeah.
Do I have 2x? Yeah. What the heck do I do with the dx? Look at this. Can I solve it for du? Multiply. So I would really say du equals 2x dx. Does that make sense? And now watch this. I have 2x dx. I have a 2x and I have a dx. So this is du. So this integration becomes, watch, ready? We're going to put it in terms of u. Do you agree that this is the integral of u squared du? Do you agree with me there? Does it make sense? Okay, because my du is 2x dx. I have that. And this is all u to the second. That's what it becomes. Okay. Now, can I say something real quick? This right here, we don't write that. I just showed you that's why we write it. If I were to do this problem, I would write u is x squared plus 1, and I'd write du is 2x dx. I just write a dx by, or whatever it is, if it's dt or d theta, right? I just write it next to it. I don't show that work, okay? I just throw the dx at the end. Okay, so now we integrate. Hey, it's a power rule, right? What's the integral of u squared? U cubed over 3, don't forget, plus c. Am I done? Circle my answer, call it a day. No, because what did I ask you about? I asked about the integral in terms of x, right? Did you answer in terms of x? No, you have to give your answer in terms of x. So let's go back to the x world, plug it in, u-substitution. Plug it in. Plug it in. We get x squared plus 1 quantities cubed over 3 plus c. That is f of x. That's it. What do you think? Not too bad yet. Am I in the way? I can move. The glare on the screen is rough. I'm actually gonna switch over here. Okay. Oh, I've seen that song for my jazz trio. Wait a minute. All right, next one. Take a look at number 2. It's in terms of t, okay? If there is a quantity to a power or whatever, your u is typically that. You want to look for a u and then it's a derivative has to be in the same problem. Any guesses as what I'm going to make u in this problem? The first one, yeah. U is going to be t squared minus 2t plus 7. Okay. Now, what is the derivative, the du?
2t minus 2, which would be 2.
Yep. So du is 2t minus 2. Don't forget dt, right?
Yeah.
Okay. So now, do I have everything? Check it off. I have 2t minus 2 and I have dt. So I have my u du. I'm going to rewrite my integral. This equals the integral of u cubed. All the rest of that is du. U cubed du. Does that make sense? Are there any questions yet? Okay, so we integrate. The integration is u to the 4th over 4 plus c. Final answer, I have to plug in terms of t, right? I put the original variable that I was talking about. So it's going to be t squared minus 2t plus 7 quantity to the 4th over 4 or times 1/4, however you want to write it, plus c. That represents the original function, and that is f of t. Okay, boom. Questions for me? Okay. Ready for your turn? Give it a shot.
Get rid of the second part.
Is that?
You just get rid of that du part, like, pretty much.
Yeah. What you want to make sure is that you have all of du, so that whatever the rest of it is outside of the quantity is compensated for with the du. Yeah. Okay. And you might be thinking something, and if anybody has a question, you can feel free to ask it. Yeah, so I would write u is. Good. Okay, whatever the quantity is, I made u 3x minus 1, right? Du is the derivative 3 dx, right? Do I have everything? I got my 3, I got my x or dx. All right, so this is du and this is u. So I have everything, right? So I'm good to say this becomes, I do u substitution is what this is called. So I sub in my u, it becomes u to the fourth. I don't need parentheses there really. U to the fourth du. I've accounted for everything, right? My stylus is being weird. Okay. What does it become when you integrate it? U to the fifth over 5 plus c. Okay. I'm not done though, right? Put it in terms of x. It's going to be the quantity 3x minus 1 to the fifth
Let's kick it off.
over 5 plus c. All right. Are you thinking this is pretty easy so far? No? Okay.
Let's kick it off.
Let's kick it up a notch. You might be thinking, oh, Miss Alexander, that fits so perfectly. My derivative was exactly there. It was beautiful, wasn't it? Is it always going to be like that? No, that's why I'm here, to teach you all the ways that it can't be there. Okay, so, all right. So here's what happens when it's not there. We have the integral of x times 2 x squared plus 1 squared. Hey, what do you think we'll call u? X squared plus 1? Yeah, I agree. That's raised to the quantity, right? When you have a quantity, that is typically your u. Sometimes you have to play around with it a little bit. As we get like more advanced with integration, it's not as obvious. Okay, now du has to be what? 2x dx.
What?
Now, yeah, what's the problem? Whoops, sorry, du. I'm missing, I have an x, right? I have a dx. What am I missing? A 2, yeah. So then what do I do?
Give up.
If it, yeah, beautiful. Multiply by 1/2. Like, if I have a constant, can't I easily take care of it by multiplying by its reciprocal, right? Watch this. Watch this. We're going to get really tricky. You want all of du in there. So you make it, you force it to be what you want. If I multiply this by 2, what do I need to do? Multiply it by 1/2, right? So because 1/2 times 2 is still 1, right? Am I changing anything by multiplying an integral by 1? No. But watch this. Do you see where I put the 1/2 and the 2? The 2 is part of the du, so it needs to be in the integral. Yes? I put the 1/2 where? Outside the integral. So what you're going to do is now I have my du is all of this, right? This is my du. I'm now good. I have my u, right? Is everything accounted for? Yes. Now I can do my u substitution. So this is going to be, now don't forget, what do I do with this 1/2? It comes along for the ride. It's going to now be 1/2 times the integral of u squared. The rest of that is du. What do you think? We doing okay? Okay. All right. Once you practice these, they're kind of fun. But it does take some time to get used to. Get used to it. Okay. Let's integrate. We have 1/2 u cubed over 3 plus c. Okay. Now, that's a little sloppy, sorry. So we get u cubed is going to be the quantity x squared plus 1 cubed over 6 plus c. Am I done? No? Yeah, I'm done. I'm done. I'd say I'm done, right? I substituted in. There's nothing else to simplify. This is equal to f of x. I'm done. Questions for me? What do you think of that? A little weird.
One half multiply into the.
Think about it.
That I see.
If I multiply a constant by something, is it still a constant? It's still a number. If I multiply any number by whatever, it's still going to be a number. So I just say it's plus some number, C. So I don't have to worry about it. Okay. All right. Number 5. Oh, what do you think I do first?
F.
1/2 power. Ding, ding, ding. Rewrite all radicals. Go for the rewrite. Go for the rewrite. This becomes the integral of 12x minus 1 to the 1/2 power dx. Okay, ladies and gents, what is u? What would you call u?
12x minus 1.
12x minus 1. And du is, what's the derivative? 12 dx. Don't forget your dx. Do you guys remember, do you guys know what dx, what I said dx is? You guys asked me a couple times and I just want to reiterate.
Yeah.
What the heck is dx? Think about when we did Riemann sums. Do you remember that delta x was the width, right? It was like the width of those rectangles. And what did I say? Well, what is an integration but an infinite evaluation of a Riemann, right? A Riemann sum. So as n approaches infinity, or as delta x approaches infinity. So what is dx? It is an infinitesimally small value, but it matters,
Big word.
right? Everybody say infinitesimal. And actually, I think Isaac Newton was the one who wanted to call it the math of infinitesimals, but that didn't stick. So because no one could say it, I guess. Okay, so do I have everything I need? No, not quite. Do I have a 12 on the outside? I have a u. I have my dx. I don't have a 12, right? So I got to factor in the 12. Watch this.
Yeah.
If I multiply by 12, I now have 12 in dx, right? But what do I need to do? If I multiply by 12, you better multiply by 1/12. Where does it go? Outside of the integral. 1/12. Okay? So then you get 1/12. I'm good to do my integration. 1/12 integral of u to the 1/2 du. Right? All of this is du, and this is u.
Yep, can you draw one?
Okay, integrate. You guys had some trouble with fractional powers, so I'm hitting on this to make sure we're good. What's the integral of u to 1/2? U to the add 1, 3 halves plus 2/2.
Over.
Now, I would divide by 3 halves, but listen, what could I do instead of, it would be u to the 3 halves over 3 halves, but what could I do instead? I can go right to time, oh, the stylus stinks. Okay, times 2/3. Do you agree with that? That's what I like to do, so that I have to write less. Okay, and then don't forget plus c for indefinite integrals. Okay. All right, multiply it out. Hey, what's 1/12 times 2/3? Well, 2/12 becomes 1/6. So do you see that's going to be 18, 6 times 3? This is just over 1. So I get u to the 3 halves over 18 plus c. Not done. I have to do my u substitution. Go back into the x world, plug in your x's. Oh my gosh, I can't circle. So f of x is 12x minus 1 quantity of to the 3 halves power over 18. But I'm still not done because I want you to get rid of fractional exponents because I know that you're going to have to know this in your college calc class. Okay. How do I rewrite 3 halves power? Yeah, power over root. So it's the square root of the 12x minus 1 cubed all over 18 plus c. Okay, so the two algebra things here, I want to make sure you're good with going from fractional powers to radicals and multiplying by the reciprocal with those complex fractions, okay? All right, let's go to number 6. We're doing great. You guys are doing good. Okay. Take a look at number 6. Do you want to take a guess of what we have to do first?
You have to. Bring this up.
Nice. Yeah. Hey, listen, here's a little principle here. We cannot integrate fractions with variables. So you can't integrate division yet. You don't know partial fractions. That's a disgusting part of integration that you don't have to learn in this class. So you can be thankful. But so what we need to hope for is make it multiplication and hope for the best. Hope for a UDU relationship. So we're going to rewrite this integral as the integral of negative x times 1 minus 2x squared to what power? The negative 2 dx. Okay. What is my u?
1 minus 2x.
1 minus 2x squared. Do you guys agree? Right? Yeah. And think ahead. The more you think ahead, the better off you'll be. Is the derivative similar to what I have? It's negative 4x. Well, I have an x. I don't have a constant, but I know how to deal with constants, right? So that looks pretty good to me. So du is going to be negative 4x dx. The more you think ahead, the better. Okay. Now, I need to compensate for a what? 4. I have my negative. I have the negative, I have the dx, and I have the x, right? So I multiply by 4 and then times 1/4 outside the integral. So now I have my du is the negative, the x, the dx, and the 4. I have everything now, and I've compensated for it out here. 1/4 times 4 is still 1. I'm not changing the integration. Oops. So now I'm good for my rewrite, yeah? So it becomes 1/4 times the integral of whoa, sorry, I meant to highlight that. U to the negative 2. The rest of this problem is du, the infinitesimally small value.
Done.
Okay. Oh, my poster. Okay. Okay, so then we integrate. What's the integral of u to the negative 2?
-1.
U to the negative 1 divided by negative 1. Some of you are forgetting divide by that power. Plus c. So this is 4 times negative 1 is negative 4. So I'm just going to put a negative out front. Do you feel me there? Negative u to the negative 1 over 4 plus c. So we plug in. Well, actually, that u to the negative 1 goes where? I don't want any negative exponents. Denominator. So this is negative 1 over 4u, right? Plus c. So then I can plug in now. F of x is negative 1 over 4 times u is 1 minus 2x squared. There's no power. It's just to the first, so then plus c. You can distribute, but you don't have to. I know you can distribute. I'm more concerned with, do you know how to deal with negative and fractional powers? And can you deal with complex fractions? Okay. Questions? Do you want to? Oh, yeah. Look at number 7. How would you start number 7? Ideas.
To the top.
You could bring it to the top. Was that Cassie? You could bring it up. There's also another way, and I don't want you to forget this. When I look at an integration problem, does anybody have another way? What do I always say to help you in calculus? If you can simplify it with algebra to make the calculus easier, do it. Can I simplify that? Yes. What does it become? Help us out. 9x squared, right? Squaring, 3x squared means 3x times 3x, right? That's, you can square over multiplication, just not addition or subtraction. This becomes 1 over 9x squared dx. Do I need to do u substitution here? No. I do need to rewrite it. I need to say that this is the integral of 1/9 x to the negative 2 dx. I don't need to do u substitution here. I don't need a u du. I can just integrate with the power rule. So if you can avoid using u substitution, you do. All right. So we do integral, we pull the 1/9 out. Integral of x to negative 2 is x to the negative 1 over negative 1 plus c is going to be negative 1 over 9x. Does that make sense? Okay. Plus c. Any questions? Okay, take a look at number 8. This one is a little tricky. It's a little bit of a more tricky constant. Okay. So, let's rewrite any radicals. Okay. So this becomes negative 7x times the quantity 3 plus x squared to the 1/2 dx. What do you think u is going to be? What's my quantity? 3 plus x squared, right? So that's good. 3 plus x squared. And du then is 2x dx. You know what's weird about this one? I have a negative 7. Now, you might look at this and say, well, I'm going to need like a negative 2/7. But who wants to do that? I don't even want to do that. Watch this. Watch this. Let's pull out the negative 7. Yeah? Because I can pull a constant in front. I can't do that with variables. You may not pull a variable out, but you can pull out a constant. 3 plus x squared to the 1/2 dx. Now what do I do? Can I easily deal with that 2 now? Certainly. You multiply by 2. You multiply by 1/2 on the outside. So it's really your negative 7/2, right? You could go right to, you could just go right to just like divide that by 2. Does that make sense? But I did want to show that, you know, that we are multiplying by 1/2 and multiplying by 2. So it's like multiplying by 1. Does that help? Any questions? Okay, so double check. I have 2x and dx. I am good for my du, and this is my u. So I can rewrite it as the integral of, oh, I'm sorry, negative 7/2 times the integral of u to the 1/2 du. And now I integrate. So the integration is rather simple when you get to the u part. The hard part is identifying what u is and compensating for it. So we're going to say this is, okay, help me out with this, negative 7/2. This is going to be u to what power? The 3/2 times what? We would divide by 3/2 times reciprocal 2/3. Yeah. Again, if you need to see that, it's u to the 3/2 divided by 2/3 is u to the 3/2, or you can write 2/3 u to 3/2. Okay, however you want. I just do that to save myself a step. Plus c, right? Let's plug in. We have negative 7 times the quantity, 3 plus x squared to the 3/2 over 2. Oh, no, I'm sorry. I need to multiply, don't I? Negative 7/2 times 2/3. What does that become? Okay, but watch this. Do you see that the 2's just, you can cross them off? So, do you agree negative 7/3? Okay, plus c. Almost done. I need to get rid of that fractional power. Is it square root or cube root? Square root of the quantity 3 plus x squared to the like cubed. Okay, all over 3 plus c. Did I make any stupid mistakes? All right. Boom. Okay? Last one. We can do it. We got this. Okay? Well, let's rewrite, bring it to the top. I just want to make sure you have all this. Your assignment for tonight is 4.5 worksheet 1. It's only 6 problems, okay? All right, let me do this one, okay? We get negative 5x times 3x squared minus 6 to the negative 3 dx. U is going to be
Middle.
the middle, 3x squared minus 6. Du, it's another weird one, 6x dx. This negative 5 is messing me up, right? Pull it out, you got it. So I'm going to rewrite it as negative 5x times 3x squared minus 6, negative 3 dx. Now I compensate for the 6. I put a 6 in and I times it by 1/6. So this becomes negative 5/6 integral of, I have everything now, u to the negative 3 du, and then you integrate. Okay? Have a wonderful day. See ya. I'm just going to finish my recording. See ya. Thanks. Thank you. Okay, we can simplify the negatives here. So we get positive 5/12. So your f of x is, bring this negative exponent down, you get 5 times 3. Oh, sorry, no, that's going to go to the denominator. That's the only thing in the numerator is 5. 5 over 12 times 3x squared minus 6 quantity squared plus c. And that is it.